Hello, all. Good evening. So, in this session, let us continue with the temperature topic. Yesterday, what I told you were two things: land breeze and sea breeze. So, whenever we have day or summer season, land is very hot compared to water bodies. As land is very hot, we normally observe that air above the land will also be hot and hot air rises. Because of this, water will be cooler and wind will blow from sea to land, called as a sea breeze or onshore winds. How do you know something is onshore? You need to see from where to where the wind is blowing. If it is blowing from sea to land, we call it as sea breeze. Now, if you look at this, I also gave a term called isotherms. I also gave you people a term called isotherm. What is isotherm? It is an imaginary line which joins places of same temperature. Now, please everyone look at here carefully for a while. Later you can write. Everyone, let us assume this is land and surrounding we have water. Surrounding we have water. This is equator. This is 90-degree north. Right? And as this is equator, this will be my northern hemisphere. And please see here, these are the dotted lines which indicate places. Okay, let us all assume that these are the dotted lines which indicate the places. Now I want you people to tell me on land, okay, northern hemisphere, let us assume summer season. Okay, northern hemisphere, let us assume summer season. Can you tell me which one will be hot, which one will be cold? Which one will be hot, which one will be cold? Land and water comparison. Can you tell? Now, everyone, if I consider land to be 30 degrees Celsius, okay, if we consider land to be 30 degrees Celsius, in the same area, if I consider water temperature will be just 25 degrees Celsius. If land is 30 degrees Celsius, water will be 25 degrees Celsius. Now you tell me, if I move from equator to poles, okay, 0 to 90 degree, will temperature decrease or will temperature increase? If I move from equator to poles, what will happen? Temperature decreases. So 30 degree will become 25 degree, 25 degree will become 20 degree. You in water, you tell Guys, in water you tell 25 degrees Celsius. Above that you will have 20 degrees Celsius. You will have 15 degrees Celsius. Good. Everyone, I want you to observe two things, guys. Compared to land, water must be cooler. In the same latitude, compared to land, water must be cooler because it is summer season. Second, you must observe that whether it is land or water, if we are moving from equator to poles, temperature is decreasing. Now, what I'll do, I will join places of same temperature. I will join places of same temperature. It is just an assumption that I am taking. Don't consider it seriously. Numbers are assumptions. Okay. Now, everyone, can you all see this? The red lines that I have drawn. Can I call it as isotherm? Isotherm? Yes. Can you people tell me? Can you people tell me the isotherm here, when drawn from sea to land, okay, isotherm, when drawn from sea to land, is it shifting northward or is it shifting southward, guys? Is it shifting northward or is it shifting southward? Northward. Anjali, you see this one. Northward. Is it shifting equatorward or is it shifting polewards? Is it shifting equator-wise or polewards? Polewards. Huh. Can you see here? Can you see here, guys? In this area, you see? Huh. When it is drawn from land to sea, is it southwards? Is it southwards? And is it equatorward? And is it equatorward? Yes. Now you see another one. This northern hemisphere, if you have summer season, southern hemisphere will have winter season. Now this is your land, this is water. Everyone, can you tell me winter season, which one will be hotter, which one will be comparatively cooler? Water is hotter, land is comparatively cooler. Okay. Now I'll take water to be 25 degrees Celsius. So you tell me, can I say land will be 20 degrees Celsius? Yes. Monisha, this is climatology only, ma'am. 25 will become 20 degree, 20 degree will become 15 degree. 20 will become 15 degree, 15 will become 10 degree. 25 will become 20 degree, 15 degree. Now you see everyone, How does it look? Okay. Yeah, similar. Good. But you tell me one important aspect here. Is it shifting? Is it shifting? Black dotted are latitude and places. You consider it as places, some imaginary places. Vijeta, yesterday we did why water temperature is higher compared to land in winters. Okay, please see yesterday's lecture once. Okay, now you see everyone, is it moving northward here and here? Yes, in both cases. Huh. But can you tell me here it is moving towards poles? In northern hemisphere it is moving towards poles. In southern hemisphere it is moving towards equator. Huh. You tell me here guys, you tell me here it is moving southwards. It is moving southwards. It is moving towards equator, but here it is moving towards poles. Do you agree? Okay. Yeah. Hariharan, water is not hot. Water is comparatively hotter because in the night, land will release more heat. Water will release less heat. So as land releases more heat, land becomes cooler fast. Water takes time to release heat, so it will be warmer. Guys, everyone, can you draw this? You write isotherm and draw this. Huh. Simran, we should try to look at it as water to land. When isotherm is drawn from sea to land, and when isotherm is drawn from land to sea, you should see like that. Okay? So it is like from where to where it is moving. Yes, Hariharan, terrestrial radiation from land is more compared to water. We are drawing from land to sea, ma'am. We are drawing from Tanvir, we are drawing from land to sea. Everyone drawn? Okay. See guys, please write down when. Okay. In northern hemisphere during summer season, when isotherms are drawn from sea to land, it shifts northward or poleward. And when it is drawn from land to sea, it shifts southward or equatorward. NCRT also has these topics, guys, but in a different language. In southern hemisphere, during isotherms are drawn from land to sea, it shifts, sorry, yeah, land to sea, it shifts southwards or polewards. And if it is drawn from sea to land, it shifts northward or equatorward. We just explained this now. I think some students joined late, so they're asking why this happens. See, this is what happens if you come late. Done, guys, everyone? Yes. See, guys, what happens in southern hemisphere? This is equator. This is poles. So normally what is going to happen? Temperature decreases from equator to poles. And water is hotter compared to land. Water is hotter compared to land. Now everyone, let us take the second type. Second example that we have now. Akshay, you are right, but seasons are different. Now I will draw different seasons. You will get different clarity. Northern hemisphere, let me say winter. Southern hemisphere, let us say summer. Okay? Huh. Why summer? Why northern hemisphere will have winter, southern hemisphere will have summer? Because of revolution of the earth rays. Everyone, see here. Can you tell me winter season? Winter season. Which one will be hot? Which one will be cold? This. So you see, land. I will write 20 degrees Celsius. Water will be 25 degrees Celsius. Yes. So you tell me from equator to poles if we go, can we say temperature decreases? Yes. 20 will become 15, 15 will become 10, 25 will become 20, 20 will become 15, 25 will become 20, 20 will become 15. Now if I join them, can you all check when we are joining? Is it different? Tanvir, please see yesterday's class. Winter season, land will be cold, water will be hotter. Can you see, is it reverse? Is it reverse? Yes. Guys, now you understand why we read land and sea temperature? Land breeze, sea breeze, do you understand now? See, without reading that, if we see this, it is difficult. That's why always remember, reading in order is important. Land will be hot, land will have 30 degrees Celsius, water will have 25 degrees Celsius. 30, 25. Everyone, is it again same? Please draw this. Please draw this. Water property is it takes time to get heated, it takes time to get cooled. Chandru, right? Did you draw, guys? Completed, everyone? Yet to. Okay. See this. You all observe this. Hariharan and Anbu, see this carefully. Winter season, land is cooler, water is hotter. Okay. Here, as I go from equator to poles, temperature is reducing. You see, 20 is becoming 15, 15 is becoming 10. Now, I am joining place same temperature. So what is the confusion here? Got it now? Yeah, only degrees are changing. Degrees should change, no? Degrees should change, no? Yes. Summer and winter, what should change is degree. Pattern is same regardless of summer and winter. True. Okay. Jatin, no need. No need. No need, no need. No need of that. Ma'am, this is 15 degree, this is 15 degree, ma'am. This dotted lines are different. The if diagram is not proper, I'm sorry. Okay. Water and land temperature depending on the area. Yes. That is only for consideration. Yes. Please write down. Yeah, Chandru, you're right. In northern hemisphere, during winter, isotherms shift southward or equatorward when drawn from sea to land, and it shift northward or poleward when drawn from land to sea. Next is in southern hemisphere, during summer, isotherms shift southward or poleward when drawn from sea to land, and it shift northward or equatorward second point, you see, southwards or polewards when drawn from sea to land, southward or poleward. Land to sea is northward or equatorward. Correct only, ma'am. Jai Shukla, yes. Done, everyone? Okay. Thank you. Zarana, yes. Next is we have one more, guys. we call valley breeze and mountain breeze. Okay, guys, first let me explain some concept, then I'll come to this. Desert area. Okay, desert area, daytime, night time. Guys, I have a question to you. In desert area, will you have clouds or less clouds? More clouds or less clouds? Less clouds. Okay. Will you have more humidity or less humidity? More moisture, less moisture? Less. Good. Now you see, everyone you see, if at all, clouds are not there. You tell me, if clouds are not there, can sun's rays come easily and fall on the desert? Tell me, does sun's rays come easily and fall on the desert? Yes. If water vapor is not there, can I say atmosphere absorption reduces? If water vapor is not there, can we say atmosphere absorption reduces? Yes. Now in the night you tell me, guys, in the night you tell, if clouds are not there, can I say earth radiation will be sent back easily? Earth radiation will be sent back easily? Yes. You tell me, if moisture is not there, then earth radiation is not absorbed by atmosphere much? Yes. Can I say during day sun's rays is coming easily, during night earth's rays is going easily? So if without disturbance, I repeat, without disturbance, if sun's rays will come and earth's rays will go, then it is called as radiation window. Radiation window. Okay, what is radiation window? You write below. You write valley breeze and mountain breeze. Below that you write. Anjali, I'll tell me. Jatin, earth will have terrestrial radiation. Radiation window. When the solar insolation reaches earth without disturbance and terrestrial radiation is radiated without disturbance, then it is radiation window. Because you tell me, if it is radiation window, can I say daytime it will become very hot, night time land will become very cold? Yes. Did you write this? Did you write this? Only this one is. Please write, quickly write. Are you able to link it with previous classes? Are you understanding those now? Statements? Okay. Now, everyone, when I say, please see carefully for a minute, mountain, see guys, these are mountains, these are valley. Okay, mountains, valley. Mihir, I'm talking with respect to desert. Okay, we are talking only with respect to desert, not other land. Because you got what is mountain and what is valley. These areas will be called as valley. Now you see, in the class I told you, can I say, as we move above, water vapor reduces. Do you agree? Most of the water vapor will be present within 3 kilometers. Do you agree? As we move above, clouds also reduces. As we move above, clouds also reduces. Okay. Now you see, I take an example. Okay. Now, valley is covered with clouds. Valley is covered with clouds. Now let me take it as day. Day or summer season. Mountain, I'm assuming this is an assumption, okay? Mountain is not covered with clouds, whereas valley is covered with clouds. So can you people tell me which one get heated soon? Which one will take time comparatively? You tell me. Mountain gets heated soon and valley takes time. Good. Valley takes time. Very good. Can you people tell me now? Comparatively, can I say mountain is hotter? Yes. High temperature, low temperature. High temperature leads to low pressure. Do you all agree? High temperature leads to low pressure. Low temperature leads to high pressure. Can you tell me wind will blow from where to where now? Wind will blow from where to where? High pressure to low pressure. That is valley to mountain, called as valley breeze. Some people may get doubt. Sir, how can wind go upward? Correct? How can wind go upward? Don't you think gravity will push all those things? Remember, for air to move, the primary condition is pressure differences. The primary condition for air to move is pressure difference. We call it pressure gradient force. Okay, pressure gradient force is very, very important for air to move. And I'm telling you, in UK there is a waterfalls. Okay, there is a waterfalls where waterfalls will be happening like this, and during daytime it is observed that sometime, not every time, sometime wind speed will be so high that water will start moving in reverse. The wind will push the water and it will move in reverse. That means due to pressure difference, the wind movement is so fast. Okay, the wind movement is so fast. That is what you observe in that particular area. Okay, so remember, during day or summer, mountain will be hotter compared to valley. So wind will blow from valley to mountain as valley breeze. Good. Winter I'll come. Winter I'll come. Yes, other parameters are neglected. Okay. Guys, I have a question to you. When air is blowing like this, is it convection or advection? Okay. Can you people tell me? Can you people tell me? Okay, you have this. Now let me say here, air rises, circulates like this, in this way. 1 and 2. Which one is convection? Which one is advection? Which is vertical to land? Which is horizontal to land? Please see carefully. Please see carefully. Which one is horizontal to land? Which one is vertical to land? Okay. People are getting confused. Just a minute. Just a minute. I'll show you. I'll show you this. Okay. I'll show you this. See. When I have land like this, if air is parallel to the land, I call it advection. If air is perpendicular to the land, we call it convection. Okay, this is convection, this is advection. Now this land, I am writing like this. Okay, I'm writing like this. Now you see, for this particular surface, this wind is moving parallel. Okay, this wind is moving parallel. As it is moving parallel, this is considered as advection. Okay, don't consider this point is. Don't consider horizontal. I am talking with respect to mountain. Okay, how will you be standing here? How will you be standing here? Can I say you will be standing like this on the mountain? You tell me with respect to you. With respect to you. Can we say it is advection? You see, with respect to you, is it moving vertically? Yeah, Anjali, you're standing on the slope. Yes. So this will be convection. This will be advection. Don't worry, guys. All this is only for understanding, not required. Don't worry. Yes, you're right. During day or summer, mountain is hotter compared to valley. So, low pressure is above mountain and high pressure in the valley. Wind will blow from valley to mountain as valley breeze. HT and LT are high temperature, low temperature. Done? Okay. Then yes. Jatin, if clouds are present above mountains also, then this condition is not seen. This condition will be there only if mountains do not have clouds. Now everyone, during night, can you tell me which one will release heat quickly? Which one will take time? Which one will take time? Everyone see, mountain releases quickly. What will happen to valley? Valley will be. So, what is going to happen? Mountain will have low temperature. Valley will have high temperature. So, high temperature leads to low pressure, low temperature leads to high pressure. Wind will blow from mountain to valley, called as mountain breeze. That is the condition we are assuming, Chandru. Hariharan, you tell, in the night, if mountain loses heat quickly, Hariharan, clouds absorb earth radiation or reflect earth radiation? If reflects means coming back or going. Yeah. So you see, that's why you got confused with it. Clouds doesn't absorb. He got confused, Jatin. Don't worry. See, guys, mountain breeze is also called as katabatic. Valley breeze is also called as anabatic. During night or winter, during night or winter, mountain loses heat quickly compared to valley. So, mountain will be cooler and has high pressure, and valley will be warmer and has low pressure above it. Wind will blow from mountain to valley as mountain breeze. Guys, another term for mountain breeze and valley breeze is katabatic and anabatic. Okay? Above it. Low pressure above it. Done with this? Ma'am, Sushmit, okay, Sushmit, that was with respect to daytime. Daytime, if clouds are there, sun's rays will go. Nighttime, if clouds are there, it is reflected back. Don't get confused. Kavita, there are only two seasons, summer season and winter season. We saw summer season, we are seeing sea breeze. Winter season, we are seeing like mountain breeze. Sorry, valley breeze and mountain breeze. Nothing much. We are not considering spring, autumn and all. Summer, winter. Monsoon happens only in India. Anabatic. No, no. Mountain breeze is known as katabatic. Valley breeze is known as anabatic. Why monsoon occurs in India? See, guys, I did not teach you monsoons and all. Please don't go to that. I can't explain now. Let us stick to what is there. Application of world geography to India is known. Suman, I already told you, night, summer, winter, day we are not considering. Only these two we are considering. Puja, clouds are formed or not depends upon moisture. If moisture is there, it will form clouds. If moisture is not there, it will not form clouds. In breeze, advection occurs. Okay. Yes, next everyone. You see, we have continental climate and okay. Some people are again and again asking the same aspect, so I'm telling you. Summer day, okay, summer and day are synonymous, interchangeably used. If you ask me what will happen in summer night, okay, whatever happens during night will happen on summer night also. Winter day, whatever will happen in the day will happen even on winter day. That means daytime and night time will be same. Okay, so summer day, summer night will be different. Winter day, winter night will be different. Okay, continental climate and Sushmit, yes, clouds are compulsory. Marine climate. Ranjit, that is another language. Catabatic, anabatic is another language. So don't worry. Continental climate and marine climate. Okay, see this. Now, uh, you tell me, Delhi. What is the difference between Delhi and Mumbai? Okay, Mumbai, Chennai, Kolkata, Delhi, Punjab, Lucknow. See guys, these are surrounded by land. These are closer to the sea. Okay, so this is called as continental climate. Continental climate. This is called as marine climate. Okay, now you see, if I have marine climate, that means sea is closer. If sea is closer, I will have land breeze and sea breeze. Okay, so what is going to happen? If land is very hot, wind will blow from the sea. If sea is very hot, wind will blow from the land. So what will happen? Temperature will never become extreme. Okay, whenever temperature of one is increasing, air from the other side will blow. It will balance. So whether it is summer season or winter season, temperature remains same. Whether it is day or whether it is night, temperature remains same. Okay, where in Thiruvananthapuram, you take Trivandrum near Kerala, summer temperature is 30 degree, winter temperature is 30 degree, okay, or 29 degree. Morning temperature is 30 degree, night temperature is 29.5 degree. That means morning or evening, summer or winter, temperature variation will be very less because of wind blowing from land or wind blowing from the sea. But if you take Delhi, if you take North India, if you take Punjab, if you take Delhi, if you take Lucknow, what is going to happen? Day will be very hot, night will be very cold. Summer will be very hot. Delhi summer temperature reaches to 35, 38, sometime 38. Winter temperature will be 5 degree. Okay, 38, 5. Whereas Mumbai, Chennai, Kolkata, summer winter temperature difference will be hardly 1 degree Celsius. Okay, so if any area is surrounded by land, it will be called as continental climate. If any area is surrounded by water or closer to water, it is called as marine climate. Okay, now I want you to write heading as continental climate and marine climate. Below that you write when an area is surrounded by land and if it is far from the sea, then it is called continental climate. Okay, when an area is closer to the sea and if it observes land breeze and sea breeze, then it is called marine climate. Now below this, if mountains are there, then you will have katabatic, anabatic. Okay. Now, you see, diurnal temperature. Srirang, yes. Diurnal temperature. Observes, not absorbs. Diurnal temperature. Okay, guys, diurnal means difference between maximum temperature and minimum temperature within a day. Okay, difference between maximum temperature and minimum temperature within a day, that is called as diurnal temperature. Can you tell me, guys, which one will have more difference, which one will have less difference, guys? Which one will have more difference? Which one will have less difference? Day here means 24 hours. Oh my God. Continental climate has more diurnal range compared to marine climate. Guys, diurnal temperature means difference between highest temperature and lowest temperature within a day. Yes. Please see. Within a day means 24 hours. Day and night. Daytime. Daytime. Okay. Daytime means when we have light. Night time means when sun is not there. Anjali, yes. We have annual range of temperature and monthly range. Uh, Range of temperature. See guys, ocean is huge. Impact will be more. River is small. Impact will be less. Okay. Ocean is important. You may think Yamuna is nearby. So why not effect? Effect is less. Annual range of temperature, monthly range of temperature. What is annual range of temperature? Difference between highest and lowest in a year. Monthly range of temperature, difference between highest and lowest within a day. Sorry, within a month. So we say continental climate has high annual range and high monthly range. Done? Yes, Hariharan. Weirdo, which concept you want me to explain once again? Here it is just, if continent is around, there won't be land breeze or sea breeze. If it is there, then you will have range. Range anywhere is difference between highest and lowest. It's not average temperature, ma'am. It is difference between highest temperature and lowest temperature. Let us say in a day, highest temperature was 25 degrees Celsius. Okay. In a day, highest temperature was 25 degrees Celsius. That is, I'm talking about 24 hours. Highest temperature was 25 degrees Celsius. Lowest temperature was 20 degrees Celsius. So, diurnal range means 5 degrees Celsius. Fine. Annual range, if I take highest temperature in a year was 30 degrees Celsius, lowest temperature in a year was 10 degrees Celsius. So I am going to tell it is range is 20 degrees Celsius. Chandru, sea breeze and land breeze will try to minimize the effect. Okay, next guess. You write note. Highest temperature in a day will be. Can you tell the time, guys? When will you have highest temperature within a day? Afternoon is fine. Which afternoon? Is it 12 o'clock, 12 to 2, 2 to 4? What it would be? Okay. I have a question to you. Think until, okay? Are we talking about atmospheric temperature? Yes or no? Are we talking about atmospheric temperature here? Yes. Atmosphere receives highest temperature from the sun or from earth. Atmosphere receives highest radiation from the sun or from the earth. Good. Earth is the major source. Good. Now you tell me, if earth is the major source, sun's rays will be highest at 12 o'clock. Okay. Sun's rays will be highest at 12 o'clock. And at 12 o'clock, land will become hot. Please listen. Later you write. Okay. What is happening? At 12 o'clock, sun's rays will be vertical and maximum sun's rays will be there at 12 o'clock. Now when sun's rays is vertical, land becomes hot. And land will take time to become hot. It's not like as soon as you keep something on a stove and on, it will become hot. It will take time. So earth will take some time to become hot. And after earth becoming hot, earth will radiate the heat. So for this process to occur, sun's rays will fall at 12, land has to become hot, and then air has to become hot. And that to occur, it will be 2 to 4 p.m. Highest temperature in a day will be 2 to 4 p.m. And lowest temperature in a day will be just before sunrise. Okay, see guys, if just before sunrise, what will happen? The land will be cooling. throughout the night land will be cooling. Okay, land will be cooling. Once the sun's rays will fall, again land will become hot. So cooling of land, cooling of atmosphere, both will be going on. But once the sun's rays will fall, okay, what is going to happen? You will normally have, temperature increasing. So it is observed, okay, it is observed. People have seen that highest temperature is normally in between 2 to 4 p.m. Lowest temperature is just before sunrise. Yeah, it varies with continental climate. It varies with, like, marine climate, but highest and lowest temperature are normally observed in this period. Exceptions may be there. I'm not talking about exception. This is a general understanding. Then this highest temperature is observed at 20° north. Okay, remember guys, highest temperature is observed at 20° north and not at equator, because equator is covered by clouds. Remember guys, near equator you have more clouds. Near 20° north we normally have deserts, land and deserts. Okay, in which hemisphere do you have more deserts, guys? Or sorry, which hemisphere you have more land? Huh. Vartika, that's what I'm asking. Which hemisphere do you have more land? Northern hemisphere or southern hemisphere? Northern hemisphere. So you tell me, I have land and water. Okay, 20° north land is there, 20 degrees south ocean is there, equator clouds are there. You tell me, among the three, which one will get heated soon? 20° north land is there, 20 degrees south ocean is there, 0° clouds is there. So among this, land gets heated soon. So 20° north will have highest temperature. Hariharan, earth will be radiating throughout the day. The whether it is when sun's rays is falling also earth will radiate, when sun's rays is not falling also earth will radiate. Why equator has more clouds? We will read them, guys. That I have not explained it. I will teach you. Okay, why equator has more? We will teach you. No, I'm talking in summer season, entire earth I'm telling this. Entire earth, if you take highest temperature within a year, if you take, it is present at 20° north, average temperature. Okay, throughout the year we will take average temperature and then check. Okay, Mohan, it is average temperature throughout the year. Sushmit, take 4°. Anurag, correct. Okay. Tilt we will talk later, ma'am. That is continental climate, Jatin. Yes, guys, take break. Take break. Zarana, from diurnal, monthly, and all, we get to know how much extreme weather conditions are there and which type of crops to be grown and how people are capable of handling those extreme conditions. All those studies will be done. Now, equator, I will talk about clouds covering equator later. Guys. Hariharan, yes, it's true. 20-degree north, okay. Guys, longitudes will be normally written in east and west, guys. Latitudes will be normally written in north and south. Anywhere, if we are writing north and south, it is latitudes, not longitudes. Now, Hariharan, leave those concepts. What is important, you focus. Unnecessary things not required, no? 12, next is. We'll talk about inversion of temperature. Inversion of temperature. Yes. Here we are considering only troposphere. Now, normal conditions. Normal conditions. Inversion. I have two conditions, guys. One is normal condition, another one is inversion. Now, normally in troposphere, hot air will be below and cold air will be above us. Hot air will be below, cold air will be above in troposphere. Okay, this is the normal condition. But during inversion, cold air will be below and warm air or hot air will be above us. Okay, so what is inversion of temperature? What is inversion of temperature? Within troposphere, under few conditions, under few conditions, temperature would increase with height. Temperature would increase with height. What are those conditions? I will explain this. Okay. Next, inversion of temperature is temporary phenomena and it is only for some time. This condition doesn't occur for longer duration. This will occur for short durations. I'll explain why and all. Did you write this? I didn't explain it. Okay. Did you write this first? I'll explain how and all. Yes. Now, you see, what is my thing? Normal condition. Normal condition. Land is hot. Air above the land will also be hot. And as I go above, temperature decreases. It will become cold air. Now, what is the case? If here temperature is 30 degrees Celsius, after 1 kilometer, it will be 23.5 degrees Celsius. This is what we see. But what is the condition that I am expecting now? I want land to be cold. Okay? Land to be cold. Guys, you tell me, if this is ice, if I keep my hand closer to the ice, okay, you tell me, will my hand feel little cooler? Will my hand feel little cooler? Yes. If I go away from the ice, can I say my hand will not have any impact? Normal? Yes. Now you see, if land is cold, what will happen to the air nearby? Air nearby will also become cold. And what will happen to the air little bit above? Can I say no change? Can I say no change? You see, if land became 5 degrees Celsius, air is 10 degrees Celsius, whereas this will be 23.5 after 1 kilometer. Everyone look at here. Let me assume land became very cold. Air above the land also became cold. But as I go above, there is no change. because as we move above, influence of the earth reduces. So no change. You tell me 10 degree and 23 and a half degree. Which one is hotter? Which one is hotter? 23.5 is hotter. Now let us see why land is becoming cooler. Why land is becoming cooler. Okay, you tell me now this. Winter night. You tell me winter season. Winter season. That too in the night. Okay. Can you tell me winter means shorter day, longer night? Do you agree? Yes. Incoming is less, outgoing is more. Do you agree? Outgoing is more. Now, as outgoing is more, land loses more heat and becomes cooler. Outgoing radiation, incoming radiation. Okay? You tell me guys, for land to become cooler, what is the first condition you need? What is the first condition you need? You need to have winter. You need to have winter and night. Okay? So we say the first condition is long winter night. Please don't talk about offshore winds and all this. I don't understand from where offshore winds come here. We are just talking about land. Okay, onshore, offshore. Why are you talking all those now? This is only about land. Okay, I'm not considering ocean nearby. So please don't bring other concepts and get confused. And then again you ask what will happen if onshore winds come. Winter night, land is going to become cooler. Okay. Second condition. You tell me, I'm talking about night only. In the night, one condition I have clouds. Another condition, see I have clouds. Another condition, no clouds. Can you tell me earth radiation in the night there will be terrestrial radiation, earth radiation. That means can I say earth's rays will go, it will be reflected, and will it come back? Yes. Heat is trapped. Not high altitude clouds, guys. Even low altitude clouds in the night will trap the heat. You tell me this condition, no clouds, will earth lose the heat? Will earth lose the heat? Yes. Yes. Can you tell me first condition, second condition? In which condition land is becoming cooler? In which condition land is becoming cooler? Okay. Guys, UPSC prelims they asked, when clouds are there in the night, why land becomes hotter? Okay, question was, when clouds are there in the night, why land becomes hotter? Options were, clouds reflect Earth's radiation, clouds reflect sun's radiation, clouds absorb Earth's radiation, clouds absorb sun's radiation. Now you tell, in the night, sun itself is not there. What do you have? Only earth radiation. And clouds doesn't absorb, but clouds reflect. Okay, so clouds reflect Earth's radiation. Okay, can you tell me two conditions now? Can you tell me two conditions now? First one is what? First one is what? Long winter nights. Second one is what? Cloudless sky. Cloudless sky. Okay. Guys, those who want to write down, I'll give time. Else, most of you, I don't know, guys. I am just telling you, most of the students are just interested in what is in previous slide. Whatever we are teaching, you don't hear. Later, you come back and ask same questions. See, please understand. I will give time to write. Okay, at the end, you can ask what all slides you want. Even you will be getting them. What is the use of writing down in the notes if without understanding the concept? When some concept is explained, if you keep asking show previous slide, you only think what you are doing to yourself, right? Have some maturity, guys, because you are going to become IAS, right? You can do these things later. What is the answer? Answer is clouds reflect. Hariharan, you bring lot of unwanted concepts. Okay, no change. I will explain. I'm explaining. No, wait for a while. Don't be in a hurry. We are still taking up. Yes. Kennedy, clouds doesn't absorb. Clouds reflect. Clouds reflect. Clouds reflect. I've told multiple times. Clouds reflect. Mihir, please see notes once. With increase in height, temperature decreases in troposphere. 2 classes for almost 6 hours, I explained that concept. So, we are talking only about winter, mom. Night time, yes. Third, see? Now, third. Guys, land became cold. Two conditions I took. Land became cold because of both the conditions. Okay. But now, I want to make air to become cold. Okay. See, my main thing is to get this condition. First two conditions helped me to get land to be cold. Okay. Now, what I want to do is air also to become cold. How air will become cold is an issue. Okay. Now, I have two conditions. One, air to become cold. I have moist air. I have moist air. I have cold air. Sorry. All this winter only. I have dry air. Guys, can you tell me which air becomes hotter easy? Sorry, which air doesn't absorb Earth's radiation? Which air doesn't absorb Earth's radiation? Dry air. Good. What will happen to moist air? Moist air will absorb Earth's radiation, whereas dry air doesn't absorb Earth's radiation. Okay, now you tell, if dry air doesn't absorb Earth's radiation, can I say if land is cold, dry air will also become cooler? Huh. Some people have a tendency to forget. Human brain can remember for 48 hours. Some people forget within 48 days, but some people forget within 48 hours. First class only I told, moisture absorbs Earth's radiation and it will become hotter. Okay. Air to become cold. So one condition is dry air. So one condition for air to become cold is dry air. Another condition is, guys, you might have played this with a candle. Okay. So if you have a candle with fire, have you played this? Like, have you done? Yes. Now, when we keep doing like this, nothing happens to our hand. But if we keep it at one place, normally it burns our hand, right? So, if at all, let us take, this is a cold area. Wind will just to blow like this. Okay? Wind will just to blow like this. Effect will be less. But if wind is present over the cold surface for longer duration, okay, if my hand is present on the ice for longer duration, normally what is going to happen? My hand will also become cold. So you tell me, if air is moving continuously, it is called unstable air. If air is moving continuously, it is called unstable air. If air is present at one place, it is called stable air. Okay. Now, if air keeps moving, impact is less. If air is present over cold surface for long, impact will be more. Okay. So, stable air, if it is present above, I repeat, stable air, if it is present above the cold surface, normally air will become cooler. Right? So, normally what is required? I need stable air. So, if stable air is there, stable air means what? Air is present at one place. If stable air is there, then heat transfer occur. If stable air is there, cold land would make air above also cooler. Cold land would make air above also cooler. So everyone, yes, everyone, see here, inversion of temperature right below, types of inversion. Types of inversion. If hot air is there, if hot land is there, air will become hot. Types of inversion. First type is ground inversion. Ground inversion. What is the meaning of ground inversion? When inversion of temperature occurs near the ground. That is, with increase in height, if temperature increases near the ground. Below this, conditions. First condition, long winter night. Yes. Everyone, you tell me, Delhi region, will you have long, winter season? Have you seen Delhi will become cold? Yes. Second, is Delhi surrounded by land everywhere? So Delhi will have Delhi will almost have cloudless sky. Third, guys, if Delhi is away, it will normally have dry air. Jatin, I didn't say Delhi will have long winter night. I told Delhi will normally have extremely cold climate. Cloudless sky will be there both in the night and in the morning, man. But I am considering in the night. That's it. Jatin, I am asking a very simple question. In winter season, will Delhi become cold or not? I didn't say long winter night in Delhi. Okay, I'm just asking you. In winter season, will Delhi become cold? Will land become cold? Yes, that's what I told. Okay. Delhi is continental climate, so it will normally have dry air, less moisture. Fourth, as Delhi is continental climate, we normally have stable air. I have written here, Amrit, if temperature increases near the ground. You wrote this? You wrote this? Okay. See this. You tell me, continental climate means, can we say sea breeze, land breeze is absent? You tell me, sea breeze, land breeze is absent? Yes, yes. If sea breeze and land breeze is absent, can I say wind movement is very, very slow? Yes. See this? Continental climate basically means wind movement will be very, very slow. Marine climate means sea breeze, land breeze will be more. Okay. I'll write a question, mains question. Let us try to see why Delhi has more pollution compared to Mumbai, Chennai, and Kolkata. This was the question, guys. Mains question. Okay. Now you see this. You see words. I don't remember exactly this, but I think 12 and a half marks. It was old question. Now, let me take Delhi. Let me take Mumbai, Chennai, Kolkata. First one. Winter nights you live. Winter you live. Okay. Second. What is second one? Moist air, dry air. Can you tell where will you have, okay, clouds, cloudless sky. Yeah. Can you tell me Mumbai, Chennai, Kolkata, are they closer to the coast? Are they closer to the coast? Can we say some clouds will be there always? Some clouds will be always there. Clouds are present. Delhi, clouds are less. Guys, can you tell me where will you have more moisture? Where will you have less moisture, guys? Where will you have more moisture? Where will you have less moisture? Delhi will have less moisture. High moisture. Good. Third, if only continent is there, movement will be less. Stable air, unstable air. Can you tell where will you have stable air? Delhi will have stable. Here you will have unstable. Guys, this leads to do you agree inversion? This leads to normal conditions. Okay. Guys, can you tell me now, if there is ground inversion, can I say, if air becomes cooler, is there possibility of fog formation? Is there possibility of fog formation? Yes, inversion leads to fog formation. Have you seen fog in winter season? Have you seen fog in winter season? Yes. Huh. Guys, remember one thing. I'll tell something. Even in Mumbai, Chennai, Kolkata, fog will be there, but it will be for very short duration. Delhi fog will be for longer duration. Okay. Now you tell, if fog is there, if fog is formed, if fog is formed, okay. Just one thing is, two people are asking some doubts. How Delhi is stable? Shweta is asking how Delhi is stable. See, ma'am, Delhi is surrounded by continent. Again and again, I am telling you, if continent is everywhere, air movement will be less. If ocean and continent is there, sea breeze, land breeze will be there. This is one point. Second, Delhi is not closer to ocean. If any place is closer to ocean, it will have moisture. If it is not closer to ocean, it will have less moisture. Delhi is closer to Yamuna. It has less moisture. If Delhi was closer to ocean, it would have had more moisture. Okay. Guys, you tell me now, if you have fog and if you add smoke into it, will it lead to smog formation? Yes. Okay. So in Delhi, smog is more. In Delhi, smog is more because of fog formation. Okay. This weekend we will give you one question. Right? Okay. Ma'am, this points, if you write with example, how do you write? Show India map, show Delhi, show Kolkata, Chennai, Mumbai, show that it is marine climate because it is closer to the ocean, show Delhi is surrounded by continental climate. All those you need to show. Okay. Then second inversion is valley inversion. See guys, wherever cold air is there, water vapor, if it has, it will condense to form clouds. Okay, wherever you have cold air. Water vapor condenses to form fog or cloud. Okay. Second thing, it might not happen in Bangalore for longer duration. Summer season, land will become very hot, fog is not formed. Incoming solar radiation is more, outgoing terrestrial radiation is less. So land will be hotter in summer season. So fog is not absorbed in summer season. Okay. Guys, water vapor and fog is not associated with smoke. Smoke is associated with vehicles. Okay. Fog is there. Smoke is added by the vehicles. Then it became smog. Fog did not become smog by its own. Only when vehicles enter into it and vehicles release the smoke, it will form smog. Dust particles I'm not entering into that, not required, this much is enough. Valley inversion. What is valley inversion? In the valley, if temperature increases with height, then it is valley inversion. Guess what comes from the vehicles is smoke. What comes from the vehicles is smoke. Okay. Smoke mixed with fog is called smog. Okay. See guys, in the valley, if temperature increases with height, then it is valley inversion. Everyone observe this carefully. You tell me during night, mountain and valley, can you tell which one will become hot, which one will become cool? During night, if clouds are there, mountain becomes cooler, valley will be warmer. Here you will have hot air, here you will have cold air. So as you are all aware, Hariharan, I am considering a time period when mountains do not have clouds. Okay, I am not considering when mountains have clouds. Now, guys, cold air, warm air. Can you tell me which one is heavier, which one is lighter? Density wise. Yes. Cold is heavier. So you tell me now, If cold air is like rock, hot air is like water. Okay, cold air is like rock, hot air is like water. When you put rock in the water, okay, can I say rock will settle at the bottom, water will come up? So here what is going to happen? Cold air will settle at the bottom, hot air rises. Okay, so yes, all this is for short period, because in the morning again it changes. Can you all check here? Cold air is below and warm air is above. Vinyasa, the difference is ground inversion is on a normal land. Valley inversion will be present only in the valley. The difference is the place. Okay. Can we say cold air is below and warm air is above? So can we say this is inversion present in the valley? Valley inversion. Yes. See, mountain has cold air. Valley has hot air. Cold air is heavier. Hot air is lighter. So, when cold air comes and falls, as cold air weight is more, it will settle at the bottom and it will rise the hot air. Okay. Valley will become cooler because of the cold air coming now. Anjali, valley will become cooler because of it coming. Anbu, right, you're right. Everyone draw this. Draw this. Yes, Anushka, you're right. Yeah, Lakshma, it travels from mountain to valley. Yes, cold air comes from mountain and it will settle in the valley. Vartika, I never said air will blow from low pressure to high pressure. I always said air will blow from high pressure to low pressure. I never said it blows from low pressure to high pressure. Jatin, yes. Neil, most of the times it happens. Kamalpal, no, we don't observe that. That is less. Impact of that is less. Hayat, yes. It will be less. Chandru, it will be less. Mihir, correct. Mihir, correct. Arumita, this is not convection. Air is just rising above. It is raised by cold air pushing above. Hayat, right. Did you draw? Is it done? Shall I move to next one? Yeah. Next is, you see, after valley inversion, the next one that we have is upper air inversion. Yeah, this is third. Anil, I didn't see the comment, I'm sorry. Ha, Dhruv, correct. Inversion doesn't happen throughout the troposphere. It will be there only till some height. Anil, if you have any doubt, if I have not answered, you can put it again. I'll do that. Upper air inversion. Upper air inversion. Yeah, Jatin, all this is climatology only. Okay. Yes, guys. Everyone, you see, guys, this concept we will be seeing later in detail. As of now, assume some things, guys. Okay. As of now, assume some things. I know you people are very much enthusiastic. So, uh, assume some things for a while. This is my tropopause. Tropopause. Okay. Now, you have ozone here. Huge air mass. Okay. See, what is air mass? Sometimes, when there is only land, let us take Sahara Desert. Okay, Sahara Desert. Only land will be there. No river, no mountain, nothing much. Okay, most of the area, land will be there. And when you have only land, what happens? Air above the land will have almost same temperature, same humidity. Okay, same temperature, same humidity. Air mass, mass, mass. And see, guys, if it has same temperature, same humidity, it will also have same lapse rate. It will also have same lapse rate. So you will have same temperature, same humidity, and same lapse rate. Okay. So now this is stable. That means it is present at one place. Now you see, I will take layers A and B. Okay. Everyone, you see, A and B. Can I say it is very far from the earth? It is very far from the earth. Yes. If it is very far from the earth, can I say it is not under the influence of earth directly? It is not under the influence of Earth directly. Yes. Now, can I say A and B are closer to ozone? Can I say A and B are closer to ozone? Yes. If A and B are closer to ozone, can we say that A will have impact of the ozone? You tell me. You tell me. If this is ozone, if my hand is closer, if this is hot, okay, if this is hot, if my hand is closer, I will feel more hot. If my hand is away, I will feel less hot. So A may become hot, B is away, so B will become cold. Okay, see guys, I am assuming, I'm telling you, I'm assuming. What is it that I'm assuming? Air is stable. Air is stable. When air is stable, air is not moving vertically, air is not moving horizontally. Air is at one place. When air is at one place, what is happening above air is in contact with the ozone. That means it is closer to the ozone. If something is closer to the ozone, it will be warmer. If something is away from the ozone, it will be cooler. Okay. Anjali, compared to troposphere, ozone will be hotter. Okay. Compared to this, ozone will be hotter. Can you all see here? Can you all see here? Cold air is below and hot air is above. Can I call it inversion? Can I call it inversion? Yes. Is it happening near the ground or is it happening in the upper air? Is it happening near the ground or is it happening in the upper air? It is happening in the upper air. So it is called as upper air inversion. Do you understand why it is called upper air inversion? Yes. Can you write? Please write this. Yes, Kennedy. It has ended there. Ozone will become hot because of sun's rays. Okay. Vinod, same temperature, same humidity. I will explain in air mass concept. There is a concept called as, air mass. There I will explain. Don't worry about it. Kavita, don't worry about it. Kennedy, you're right. You're right. Vinod, this is not regularly observed. Once in a while, geographers have found it. Okay. Hayat, we did not talk about atmospheric stability, so don't worry about it. Did you draw? Done with this? Done. Okay. You right? Whenever there is stable air mass which extends from ground surface till tropopause, then upper air layers near tropopause is under the influence of ozone. Due to this, air layers closer to ozone will be warmer and away from it will be cooler. Due to this, within troposphere, as we move above, temperature increases in upper air. This is called upper air inversion. Though that is property of black color to absorb heat. Lakshma Reddy, this occurs whenever there is stable air mass. So what is this stable air mass and all, we'll see later. Yahya, you're right. Did you write this? Guys, last one. We have frontal inversion. See guys, a guy by name Pritesh Sisot, he just joined, he just joined and he has commented he is not understanding. This is not the proper way. We get to know when you join, when you leave and all. Okay. So if you just join and if you say not understanding, then all our efforts of teaching all these points, what is the use? If you were not there in the class, how will you understand the previous one? All these are done. All these are done. Zarana, the measurement is normally done with thermometer. Hariharan, yes, lapse rate will not be there. Yeah. Okay. Zarana, I didn't understand. What exactly is the question? No, ma'am. How do they measure temperature above and temperature below? At different layers, they normally send. And today, trust me, your satellites and all are so accurate that every layer they are in a position to calculate the temperature. Okay. So this last point you see. Uh, Guys, I have cold air, I have warm air. Okay, I have cold air, I have warm air. So if I have cold and warm air converging, which one will raise this? Which air will raise? Warm air will raise. Correct. Okay. Can you tell me here? Can you tell me here? Is warm air rising? Is warm air rising? Is warm air rising? Yes. Can we say after a point cold air will be below, warm air will be above? Yes. Is this inversion of temperature? Yes. Guys, the region where warm and cold converges is called as fronts. The region where warm and cold converges is called front. Front is a boundary between warm and cold air. Okay, so what is frontal inversion? Near the fronts. What is fronts? That is the slope between warm air and cold air. Near the fronts, we normally observe that warm air raises above cold air. So cold air is below and warm air is above. That is, there will be frontal inversion. Anjali, this will be formed near subpolar region. That we will see later. Yes, I will draw a diagram. You will not understand the diagram, but write it in the notes. Later you will understand this. In further classes you will understand. Uh, for creation of various inversions, the requirements are same. It varies. Hariharan, right? This is dynamically induced. It is not polar vortex. All these are temporary only. Sushmit, subsidence inversion basically means cold air. If air becomes much cooler above, the cold air comes down and warm air rises. That is called subsidence inversion. Not required. These four are enough. Vartika, it may occur in other layers also, but we are considering only troposphere. It can be in both northern and southern. Okay. Guys, you see, in the valley, if temperature increases with height, okay, then it is valley inversion. If you didn't write, okay, I'll give one more here. You see, for valley inversion, you see, during nights or winter, mountains are much cooler compared to valley. Due to this, cold air is formed on the mountain and yes, this is for valley inversion, and warm air is formed in the valley. Cold air is heavy and it descends. Yeah, this is for valley inversions. Cold air is heavy and it descends from the mountain and it rises warm air. So, in the valley, cold air will be at the bottom and warm air rises. This is called valley inversion. Subsidence inversion means whenever air above becomes cooler, it would come down and rise the warm air above. That is called subsidence inversion. Don't worry about it. Hariharan diagram of frontal inversion we will see in occluded front. As of now, don't worry. Okay. Thank you guys. We'll meet tomorrow. The class is done. Okay. Which NCRT to read? Seventh NCRT and 11th NCRTs. Same. Temperature rulings. 11th is also fine. 11th temperature chapter is there. That is fine. Yeah, along with notes. Thank you, guys.